indirect measurement. It's how we measure something that's difficult to measure. All right, so in this case, the problem is asking me you've got a person that is standing 12 feet from a street light. He casts a shadow as shown. He casts a 3-foot shadow. He also stands 12 feet from that street lamp. It's 12 feet. All right? Assume the triangles are similar, which is nice. It tells us that if they're similar, then corresponding sides are proportional. So what we can do is we can set up a proportion. What is the ratio? That's going to be important. We're not actually solving for missing side. We're finding a ratio. That's a fraction. Ratio of the height of the person to the height of the street light. So what we're going to do is we're going to set up a ratio. Person to street light. All right, person to light. I don't know. Can you guys see that? I don't know. I'll trace it so it's a little bit easier to see. So person to light. So person to street light. Person to street light. There we go. A little bit easier to see. So that's what we need to find. We need to find a relationship there. So let's start off with our person. Person's a little bit easier. We can trace him. I made him green. So there's my person. 5 feet by 3 feet. Okay, cool. So I have some lengths for the person. Now I need to get the street light. All right. So here's my dilemma. I don't have any of these lengths. I don't know the height of the street lamp, so I don't know that. Here's my lamp. But I do know the bottom length. That bottom length is 12 plus 3. So 12 plus 3 is 15. So now I can set up my proportion. Person compared to light. So my person is 5 to x, right, because these two are corresponding. They're in the same location. Should be equal to 3 over 15. Well, because those are in the same location. Which actually that leads me to my ratio. That tells me that my ratio, comparing the two, is going to be 3 over 15. What does that simplify to? 1/5. Good. So 1/5 is my relationship. So the height of the person is 1/5 the height of the street lamp. Oh, all right. So that simplifies to 1/5. Now, what I want us to do is I want us to go to the first problem on the notes slide. And now it says, what is the height of the lamppost then? So now we can use that ratio 1/5, or we can use the proportion that we have. And we got this proportion from the previous problem, right? Got this proportion from here. 5 to x is 3 to 15. Coolio? And so all I have to do now is remember that it's person to light. 5 over x is 3 to 15. It's 15 because of the 12 here. And that gives me a total of 15. And x. So we set up we just cross multiply. I'm just picking up where we left off last class. 5 to 15 is 45. Oh, no, that's not 45. 75, thank you. 75 for the x. And we get that x equals 25 feet. Right? So that's the proportion we set up from last time. The idea is we used indirect measurement. We separated the two triangles. There's a triangle here for the man and the shadow. There's a triangle here for the lamppost and its shadow. Okay? We just take those two triangles and separate them. That's what you'll need to do for today's work. Okay, so you can find a ratio. We can find a ratio from this. That's this value simplified. Or we can find an actual height. You just solve for x. Okay, so depending on what the question is asking for, you need to give the appropriate answer, right? Okay. Now let's get to the new stuff, right? The new stuff. We can use similar figures to help us find area. The rectangles below are similar. We're told that. Similar means for us that the corresponding sides are what? Corresponding sides are proportional. Roman's the only one who knows it. Awesome. Find the area of the smaller rectangle, which means I need area equals base times height, right? That's what area is. So A equals base times height. What's my base? What's my base on the smaller rectangle? 25. What's my height? Oh, I don't know it. It's x. So I'm going to have to do what? What am I going to have to do in order to find the area? Find x. So, just for the sake of consistency, let's do little over big. You guys remember that from yesterday? Little over big? So let's set it up. Which two sides are going to be my most helpful sides? Yeah, 25 and 40. So 25 over 40 is going to be equal to what two? What two sides? X over 16. Remember, corresponding sides are proportional, which means I can set up a proportion as long as I'm comparing corresponding sides. So let's cross multiply and solve. 40x. For the sake of time, 25 times 16 is 400. 400 divided by 40 is pretty easy. X equals 10. So now what this ends up being is 25 times 10. 25 times 10, or, thank you, or what? 250 what? Inches squared. So really, is this a new problem? No, this is just combining what we did yesterday with what we've done for the past few days, right? It's just taking what we did yesterday and applying it to what we've already been doing with area, okay? Questions on this problem? I don't think this problem is too much of an extension. It's a little bit more, right? You set up a proportion to find the missing side, then you use those sides to find area. Okay? Could you do this with the triangle? Could you do this with the triangle? Yeah. The only thing that's different would be what? 1/2. Could you do it with the parallelogram? Yeah, the only thing that's different is you need to make sure you find the height, right? Not necessarily the missing side. Last thing, sometimes we're only given a similarity ratio to work with. That's kind of what we found on the first problem that we did today, a ratio. A similarity ratio is just a comparison. It's telling you what the comparison is. So if I say, oh, that person is half the size of that person, that's telling me that the smaller person is 1 to 2, meaning that the bigger person is twice the size of the smaller person. Probably talking about like 3-year-olds and 12-year-olds, right? That's okay. We still, yeah, we hope. We just set up the proportion the exact same way. The only difference is we set it up with the ratio. We're told that the ratio of the lengths of two similar triangles is 4 to 7. So we have this ratio. We can write ratios as fractions. You remember that, right? You can write a ratio as a fraction. You can write it with the word 2. You can write it with the colon. For our sake, we're going to write it with as a fraction. Now, which of these two numbers is the littler one? Which one's the littler one? Okay, so this one's the little, and this one is the big. So that means when we set up our other fraction, our other comparison, how should we set it up? What do we need to make sure about our other fraction, that it's set up how? Little over big. So let's get the rest of our information. The smaller triangle has a side length of 16 feet. What is the corresponding side? We don't know that, of the larger triangle. So we've got x and 16, right? Where are they going to go? Where's the 16 going to go? Top or bottom? Y on the top. Anicia. He says smaller triangle, right? That's the little. Oop, I wrote that in yellow, not orange. Smaller triangle is the little. The larger triangle is our x. That's the value we don't know. So let's cross multiply and solve. Or, you see a faster way to get it? You see a faster way to get it? 4 times what? 4 times 4 is 16, so 7 times 4 is x equals 28 feet. Now if you want to see the cross multiplication, I'll show it to you now. So the only difference is that you were given the ratio, which tells you what the comparison is. You just use the ratio in your proportion. No biggie, right? We just use the ratio as one of our fractions in our proportion. And how did we know that the 16 went on top? Because in the given ratio that was given to us, 4 is the smaller number. So over here, the smaller number needed to go on top. So that's how you can use that ratio. The smaller number and the bigger number will tell you where these other two are going to go. Okay?